Blind or buried vias. So my name's Greg Steiert. I'm a local of Pacific Northwest, grew up kind of in Beaverton. I'm in Olympia now. I'm the guy with the noisy business card. See me afterwards if you want to check it out. Yeah, so a while ago I was working actually at Maxim and designing some chips that a lot of them were wafer scale, and I wanted to kind of play with them, kind of work your day job into your hobbies a little bit, and having challenges. So I kind of dug into this a little bit and found some tricks to make it a little more cost effective. Also trying to find ways to do more like low cost dev boards. So I'll talk about some of the stuff I learned along the way. Real quick, some background. In general, I'm going to jump between mils and millimeters a lot in this because some of the times the tools or the vendors may spec in mils and the BGAs are all in millimeters, so I apologize for that in advance. But here's a quick rough scale that we're going to use. When somebody says like a 5 and 5 mil trace, the vendor that will consider that about the same as 0.125 millimeters. Some weird things like when you get down to 3 mils, it's about like 0.8 millimeters. They kind of round off a little. And a couple other terms I just wanted to kind of outline here. So with vias, a lot of times they spec the diameter, and obviously the hole size is what they're drilling. There's another term called annular ring, and that's the difference in the radius of the drill to the tool. So I've got that view listed here, but the reason they specify that and why it's important is that it's not always dead center. They need some ability to slop, and that's one of the things you're going to find with some of this is a lot of this stuff and their capabilities are how good of registration they have between all the different layers that they have to stack together. Another thing I've got on this showing what a blind and a buried via is. So a blind via goes all the way to the exterior layer, but it doesn't go all the way through the board. A buried via is actually between inner layers, and it's not visible at all from the outside. If you think about what it takes to create these, it'll kind of, my goal was try to minimize the cost, and you can talk to the vendors and they'll walk you through this, but the bottom line is if they have to drill a hole that doesn't go all the way through the board, that means they have to take those layers and drill them separately, and then take all these pre-drilled layers, put them back together, and then add in the holes that go all the way through the board. So every one of those steps they do just makes it more expensive. So it really drives the cost up. Another thing, sometimes one way people like to do with BGAs is do the via in pad. Well, if you look at a via, naturally it would be hollow in the middle. It takes more steps to fill it and make sure it's flat so that you can attach your BGA to it. So that actually drives the cost up too. So when I was trying to design these to avoid these costs, I avoided blind or buried vias and via and pad. And to look at some of the specs, so here I've got the KiCad, their constraints manager here, and alongside it I've got the OshPark specs for what they do with each of their different services, the 2-layer, 4-layer, and 6-layer. One thing to keep in mind, these are their published specs, and one thing you'll find with all of these vendors, technology keeps getting better, and they're very, very slow to update their website with what their true capabilities are. The more they push you to do the wider traces and spaces, it just makes their yield go up, so everything gets less expensive. So in general, if you have this space, try to make it as wide as you can. But also, when you see these numbers on their website saying what they're capable of, realize those are kind of like guidelines, that their true capabilities of almost every board house far exceed what they're publishing on their website. Because they basically want, if you follow the rules on their website, that they're going to have perfect yield every time and it's not going to cost them anything. But you can push these rules. I say kind of, rules were meant to be broken. So there's a fair bit of that with this. But there are costs for doing that. So again, these are the board specs. We talked about the annular ring. Otherwise, the space and trace is pretty simple. The other thing is the minimum through hole. So the drill size. That's kind of important because, like with OshPark, you can fudge the trace spacing and width, and they don't check that. They won't block that. But you can't specify a drill smaller than they've got because they'll cost them at the vendor. They'll have to put different bits in. So you can't sneak that through, but you can sneak through different trace widths and spacing. So let's look at some of these, what the numbers work out to be for wafer level chip scale packaging. So here I've kind of outlined all the specs. So the real thing that kind of drives it all is the pitch. That's the space between the bumps. And in the middle, the green part is a potential via. That's how big your via could be. So you kind of start from the pitch. A lot of people have different sizes for the pad size. In general, I usually just kind of target about half the pitch for the pad size. That works most of the time. Some people recommend more, and honestly, there isn't really much of a standard. You can do almost whatever you want with some caveats. You got to talk to your manufacturing people too. But if you're going to hand assemble some of this stuff, shoot for about half when you can. So that drives out the space between the bumps is about half the pitch. And if you take just the same space and trace, that means you divide it by 3 and you get what your trace and space sizes are. Then if you look at that diagonal between the two pads and you subtract 2x the space, that gives you your maximum via diameter. So this just kind of shows what those kind of work out raw if you kind of play by the general rules. And you'll see for 0.8 millimeter, this actually works. I think it's kind of to the letter of Osh Park for their 4-layer board. You can do this with their 2-layer because you just are shrinking the via pad a little. It still works. So the number one, for 0.8 millimeter pitch, you can do that all day long. It doesn't really take any special rules to do that. The 0.5 and the 0.4 millimeter, this is where it gets kind of sketchy because you can see at your trace and space, the 0.08 millimeter, it's like a 3 mil trace in space. So you've got to use 3 mil rules to route traces between pads on that. And if you look at the dimension of the via, the 0.29 millimeters, that's like 11 mils. So that's not even, so if you have any annular ring, like you put a 3 mil annular ring on that, that's -6. So now you're in a 5 mil mechanical drill. Believe it or not, that is available. Board houses can do 5 and even 4 mil drills. And actually, honestly, if I were working with a board house, I would say, okay, I've got a 10 mil pad here. I don't care if you put a 5 mil drill or a 4 mil drill, as long as you can keep it in that. It doesn't matter to me how big the hole is. So, but you can get a 10 mil via pad. But you notice that for the 0.4 millimeter, you can't even fit a 10 mil pad in that. So that gets challenging. Oh. Question or? All right. Okay, so now let's look at what I did. Okay, so I was at Maxim and I designed a couple circuit boards. I actually have them here. And actually, when I was there, we wanted these to kind of be open source friendly. So they actually put the files on GitHub. Now, somewhere in the transition from Maxim to analog, that GitHub repo went away, but I cached it before, or forked it before. So I've got a copy here. You can go to this and see an example. Unfortunately, it's in Eagle. This was before I saw the light to KiCad, but the KiCad, the importer is a great tool. You can use that to view these files. Yeah, and afterward you can come up and see these boards. So these boards, the little one in particular was what they used for their debugger, and I think they still use that today. It's like a $10 SWD debugger, and I designed the board in Eagle. And that uses the rules kind of you see here on this one. So this has been built in multiple thousands. They order them batches by thousands. They're still selling it. It's one of their more popular dev boards, or it was at Maxim when I was there. One of the things I had to do was to get the via to fit, I wanted at least a 10 mil pad. So I shrunk the ball pad down to 0.18 millimeter instead of 0.2. So then that fit, and then with a 5 mil drill, they could put it in the middle. Again, I don't care if it's 5 or 4 mil drill, you get to do that, and everything kind of works. Another thing I would do is, it's less than 3 and 3 mil space between the pads, even at the 0.18. So I went with a 3 mil via and a 0.25 mil space, because if you look at the circle, it doesn't actually get to 0.25 for very long. It's just a short period of time. It goes through there. And I wanted to make sure that I could get some current through the trace. You don't have to worry about getting current through spaces. So anyway, I shrunk the space a little bit more than VIA. And it also helped me fit the VIA in between the pads when I shrunk the space. So that's how I got that pad. And this kind of works. And so when we built these boards, we actually had Seed Studio, their Fusion, do it. And when I sent it to them, actually the first prototypes I did with a different board house, and I talked to the guys there, and they were the ones who really recommended I stay away from the HDI, the blind and buried, and told me, yeah, we can do 5 mil drills and all that. So that's great. But eventually, for production, we went to Seed Studio. One interesting thing, when we did this, some of the first batches of prototypes, this was beyond their standard, China. The first vendor, their primary one, their low-cost vendor, had trouble and the yield was bad. So they actually had to switch PCB vendors to do these specs. But they still found it domestic, and it was still very cost-effective. But it wasn't the dirt cheap like 2-layer guys. These are all 4-layer. And that's another thing. I usually try to do 4-layer. You want some ground and power planes underneath these. But so this looks what these specs kind of look like in KiCad to do these different rules. So the 0.4 millimeter, I've got the cheat specs are in the green. I've never actually designed a board to the other 0.4 millimeter numbers. I would do the 0.5 and like, again, the 0.8 millimeter, those rules you can use all day long. No problems there. There is another trick that I've seen. I've got some test boards, but I haven't built it yet. But another trick especially for those 0.4 millimeter. Okay, but before I do that, one thing I want to say about breakouts. So again, I was talking about the 4-layer stack-ups. So if you add power and ground planes, then break out the signals in 2 layers. And one thing I just want to say, mathematically, if you use this pattern, you can break out any 10 by 10 array with 4 layers. There's actually only 2 signal routing layers. I don't recommend doing something this dense without power and ground planes, but theoretically that could be done in 2 layers. So here's a pattern that does that. Technically, a 6 by 6 array, you can do it all top layer. So, and that's what I'm going to get to with the next trick, another method to squeeze these through. So we talked about shrinking the pads, but sometimes you don't have to shrink the pads in both dimensions. And actually, you may shrink it in one dimension and make up for it by growing it in a different dimension so that the area stays about right. So I saw this in an app note or something somewhere, but for me, for a 0.5 millimeter, this gets you to a much better space, like 0.1 millimeter. That's actually like a 4 and 4. So with this, in a 0.5 millimeter pitch WLCSP, you can actually do 4 and 4 space and trace to do this. So like I said, a 6 by 6 array, you can do all on the top layer. So you don't have to worry about having the tight vias. This doesn't require the drills. And this is something you can do at Osh Park, which is great. And actually the 0.4 millimeter, it gets you down to 3 mil space and trace. And believe it or not, so Osh Park says their 2-layer is 6 mil space and trace. I've got a couple examples here where I did this 0.3 millimeter, or I'm sorry, 3 mil space and trace at an Osh Park 2-layer, and it comes out. The real thing here is when you're like making up your own rules like this, they can do it, but if you get a batch that doesn't yield, don't blame the vendor. Don't give Osh Park a hard time because they couldn't do half of the space and trace that they guarantee. So that's the one thing I want to say there. They can do it, just don't give them a hard time if you get a bad batch. So the dimensions are here. And this is what I say, like for a 6 by 6 array, single layer, you can break it out. It's just mathematical. You can get all the signals out. So there's a ton of like PMIC chips and stuff that may come in this. So you can use those in an Osh Park 2-layer board and break it all out on the top layer. Again, the real thing, you can cheat with the space and trace, but the drills are something you can't sneak by Osh Park, unfortunately. The people like JLC PCB, they have an online thing, and if you try to shrink the traces, I think they're going to jack the price up pretty quick, so it doesn't necessarily work there. But if you're talking with a regular board house, and you're working with somebody and they're just doing manual quotes, they know what stuff adds money, and it's going to work out. If you're helping them save steps like this, it'll bring your cost down. Um, and yeah, again, if you're working with some of the smaller players, even in China, the ones like that don't have the online stuff and they're doing more stuff manual, working through this stuff, if you're saving them steps, they're usually going to give you a break on the cost. I think that. So here is actually the boards. I told you I just got some boards from Oshpark. So this is a 0.4 millimeter pitch WLCSP, and you can see I drug traces between the pads using the oblong pad. Again, the registration of the solder mask is another thing you have to watch out for with this. I ordered the board, same design, in After Dark and in the purple, which is kind of nice because one lets you see where the traces are, and the other one kind of amplifies the solder mask a little more. So this one came out great with the solder mask registration. Again, Oshpark boards in general come out great, but that's another thing you might find is the solder mask registration and how that lines up. You know, you may get some solder mask over the pad and it might not come out. The oblong is a little hard to see in these. Oh, my pictures aren't great, but yeah. Oh, yeah. Oh, so, I'm sorry. Yeah, the oblong pads aren't real easy to see there. And I got another design. I did two. Basically, what these are is they're SO8 adapters for WLCSP microcontrollers, so I could fit into a board that had an SO8 pinout on it. So this is something you can do with Oshpark, and these are 2-layer boards. Again, they're using basically a 3 mil space and trace routing between the pads. They've got big vias on them, but yeah, and if you want to see the boards, I brought them with me in more detail. And that's pretty much my talk. The main thing, you know, is talk to your PCB vendors. You know, for little ones, for hobby stuff, they may not talk a lot, but if you can get some, actually there's a lot, I get emails from them all the time, different people who want to do this stuff. So, you know, you can work with them. The specs they publish online are what they can do all day long with 100% yield. They're very super conservative, and you can often go beyond that. So avoid things that add steps for them in the manufacturing process, like blind and buried vias or via and pad. Just in general, if you're saving them money, it'll usually save you some money. And kind of the rules were made to be broken. So all of these things are kind of guidelines or rules of thumb, but you can kind of make up your own rules. But I do want to emphasize again, if you're making up your own rules, Oshpark, you know, they'll let you run these boards through there, but if you get a bad batch, your solder mask didn't line up this time or something, you give them a break. You know, it's not what they promised you. So, any questions or anything? Yeah. Huh? I haven't done that myself. I've seen it in an app note somewhere. I can't remember where, but I haven't done that. Yeah. Okay. Cool. Thank you. Yeah. Oh, and just for the recording, she did mention that JLC PCB does do via and pad for free, but again, if you use these rules to avoid the via and pad, it saves money at a lot of other vendors. I have not tried LDI yet. Yeah, no. Again, my current stuff that I'm doing is more hobby, so I'm doing more like Oshpark or PCB Wade or stuff. So, yeah. Where did I learn all this? So, well, so actually, that's part of it is talking to your PCB vendor, the guys who, when you're making a quote, their service people can help walk you through some of these tricks, but usually the full service ones, the ones that are online, not as much. Although I have to say, I sent some tech questions to Oshpark, and they're very responsive. Actually, I told them I was going to be talking about this stuff before and bounced a couple things off of them, and they're very responsive with their support. And I know there's some of the vendors. I've heard great things about King Creddy. I haven't worked with them a lot yet, but I might send some stuff to them. But most of the vendors, they're hungry for business, and they'll talk to you if it's, well, I guess, I don't know, I've been doing, I guess I've been looking more at some of the low-cost ones, but I don't know all of them out there. Anything else? Cool. So great. Well, hey, thanks, and I hope this was useful. And yeah, I put links. Yeah, I got links to those couple designs in there, and we'll find a way to share the files online. This is being recorded, and it'll be available in the recording for people. So thanks.